Good morning, dear students. Let me continue the class 9th chapter is matter around us pure. Okay, we have discussed about the three types of mixtures in the last class. They are solution, colloids and suspensions, and how to separate the mixtures, how to separate the colloidal particles. Okay, we have discussed in the last class. In today's class I'm going to explain you about how to separate the liquid particles from mixture, how to separate the gaseous particles from air, and what are the applications of these separations. Then the next concept, physical and chemical changes. What is the difference between physical and chemical changes? Then types of pure substances. Okay, the types of pure substances, uh, they are elements and compounds. The next concept, what is the difference between the mixtures and the compounds. Okay, let me start the new concept now through this activity. First I will show you the video how to separate the liquid particles from a mixture. Okay, how to separate the immiscible liquid from the experiment. I will show you through this activity.
Separation of immiscible liquid mixtures. Objective: to learn the method of separating the components of immiscible liquid mixtures using a separate funnel. Mixtures of liquids can differ based on how easily they blend together. When liquids do not mix together and form a homogeneous mixture, we say they are immiscible. A mixture of immiscible liquids can be separated using special laboratory equipment called a separating funnel. The separating funnel is a cone-shaped glass container with a globe-like top. It has a stopper at the top and a tap at the bottom. Using a separating funnel, let's separate a mixture of oil and water, two liquids which cannot be uniformly mixed. We'll begin by pouring the mixture into the separating funnel. Next, we'll close the stopper. Shake the funnel gently and set it aside for several minutes. You'll see the two liquids beginning to pull apart. Water, because of its higher density, will travel down into the conical part of the funnel. Oil, which is less dense, will float on the surface of water. Now, we'll place a beaker underneath the separating funnel and remove the stopper. We can open the tap and let the water collect in the beaker, closing it once all the water drains out. The remaining oil can be collected by placing another beaker beneath the funnel. Now the two immiscible liquids have been completely separated. Summary: immiscible liquids are those which cannot be uniformly mixed together. A separating funnel can be used to separate mixtures of immiscible liquids.
Okay, in this activity you have seen that here they separated the two immiscible liquids. Okay, using the separation method. Okay, here what are the application of separating this immiscible liquids? What are the application? It is used to separate the mixture of oil and water, such as kerosene with oil and all. So it is used to separate the mixture of oil and water, and it is used in the extraction of iron from its ore. Extraction of iron from its ore. This method is used. So here which principle is used? The principle used here is the whenever there is a mixture of two immiscible liquids, their density may vary. Their density is not similar. So which have the higher density, they will be settled down, and which have the lower density, they will float on the toppermost level. So based depends on the density, we can separate these two liquids. So the principle used here is separation depends on their density. Based on the density, we can separate the two immiscible liquids. Now let us move on to another activity. Okay, how can we separate a mixture of salt and ammonium chloride? Let us see through this video.
Take a clean and dry china dish and put 5 grams of ammonium chloride in it. Take a tripod stand and place a wire gauze on it. Place a Bunsen burner under the tripod stand. Place the china dish on the wire gauze of the tripod stand. Carefully cover the china dish with an inverted glass funnel. Close the stem of the funnel with a piece of a cotton. Turn on the Bunsen burner and light it using a burning matchstick. Note: ensure you light the burner under adult supervision. Heat the ammonium chloride for about 5 minutes. Observe what happens to the ammonium chloride upon heating. Record your observations in a table. After 5 minutes, turn off the Bunsen burner and allow the ammonium chloride to cool down. What do you observe? Record your observations. You must have observed that when ammonium chloride was heated, it directly turned into vapor without entering the liquid state. The rising fumes of ammonium chloride were seen in the funnel above the china dish. This process of a solid directly changing into vapor without passing through the liquid state is termed as sublimation. You must have also observed that after turning off the Bunsen burner, the vapor of ammonium chloride cooled down and changed to solid ammonium chloride again. This solid ammonium chloride was deposited on the walls of the funnel. This is termed as deposition. Thus, we can conclude that ammonium chloride directly changes from solid to vapor on heating, and the vapor on cooling directly changes to solid again.
Okay, now let us take one more topic. Is the dye in a black ink a single color? Means whether the marker or any pen contains, any color pen contains a single color, or does it contains any different colors? Let us see this through this activity.
This video shows an example of a chromatography experiment. The goal of the experiment is to separate the different pigments of ink which are present in a wet erase marker, which we'll see right here. So a vis-a-vis marker is wet erase, which means that the pigments are water soluble. We'll start our experiment by drawing a line with the marker on the chromatography paper. Then what we want to do is insert that chromatography paper into a beaker with a small volume of water in it. We can see that the water will start to rise up the chromatography paper because of capillary action. You'll note this is happening very quickly because this is 16 times speed playback. We can see that the ink, which originally looked black, is starting to separate into different colors. This is because the different pigments have different properties. Some of them are heavier, some are lighter, some are more soluble in water, some are less. Because of these differing properties, all of the different colors are going to travel at different speeds. And by the completion of our experiment, we should see some very nice separation of the different pigment colors. Now, to do analysis of our results, what we're going to want to do is to measure the distance traveled by each pigment. Let's pause here for a moment. So I want to measure the maximum distance traveled by the water and then by each different pigment starting at the line drawn on the paper. To be fair, we should be comparing the distance traveled by the water starting from the same point where the pigment started traveling. So we'll measure all of our distances starting at this point. Looks like the maximum distance traveled by the water reaches about to here, and then we can measure the maximum distance traveled by each of the different pigments. Let's continue our playback.
in this chromatography technique, what we do, we take the dye, and the dye contains the water as a solvent. The dye is a mixture of 2 or more colors. So what happens, we will take the dye and we keep the filter paper. So since the dye contains the water as a solvent, when the water level rises up in the filter paper, it takes up along with the water, it also takes up the different colors, and this dye is the dye particles, the colored particles, are soluble in water, soluble in this solvent. So which is more soluble, that will rise up fastly, they will rise up quickly compared to the other color particles. So the process of separation of separation of components from the mixture is known as the chromatography. This technique is known as chromatography. What is chromatography? The process of separation of component of a mixture is known as a chromatography. The process of separation of the components from a mixture is known as chromatography. It has a wide application. In the present days, we use advanced technology for conducting this chromatography. It have the lots of application in the medical field and in the industries and all, to separate the colors in a dye. Then what are the applications to separate the colors in a dye? Then pigments from natural colors. Okay, pigments from natural colors means if you take the example of turmeric, it is a natural color, or so many examples we can give for the natural colors. Then drugs from blood. So these are the applications. It have the lots of applications in the medical field and all. Okay, how do you separate two miscible liquids? Miscible liquids means they will mix with each other. Okay, how to separate? The process used for separating two miscible liquids from a mixture is known as distillation. We use this method, distillation process we use.
Distillation. We know that different methods are used for separation of different kinds of mixtures. But do you know how a mixture of two miscible liquids can be separated? Well, such a mixture can be separated by a method called distillation. Distillation is the process of separating miscible components of a mixture that do not decompose upon boiling and have sufficient difference in their boiling points. The process involves heating the liquid until boiling and then capturing and cooling the resultant vapors. The separation of liquids is usually achieved at their respective boiling points. The more volatile component vaporizes at its boiling point and then condenses in the condenser, while the other component is left behind in the distillation flask. Thus, separation of the mixture is achieved. Can you separate a mixture of acetone and water? Yes, it can be achieved by distillation. Let us have a look at the procedure of separation using distillation method. Firstly, take the mixture in a distillation flask fitted with a thermometer. Observe carefully how the apparatus is arranged. Then, heat the mixture slowly, keeping a close watch at the thermometer. See the acetone vaporizing and then condensing in the condenser. This acetone can now be collected from the condenser outlet. On the other hand, the water is left behind in the distillation flask. Do you know there are several important applications of distillation? Let us discuss a few important ones. Distillation is employed in food processing to produce distilled beverages. Large-scale industrial distillation is widely used in petroleum refineries, petrochemical, and natural gas processing plants. Production of essential oils and herbal distillate is carried out by steam distillation. In addition to these applications, distillation is also used to separate the mixture of ether and toluene and the mixture of hexane and toluene.
What happens? What is distillation? The process of separating two miscible liquids from the mixture is known as a distillation. Here we have to take care that there should be sufficient difference in boiling point. There should be difference in boiling point and the boiling point without decomposition, and we have to see that while boiling we boil the solution, we boil the mixture without decomposing. Okay, we don't allow them to decompose, and there should be sufficient amount of boiling point difference should be there. Okay, in order to separate the petroleum product, we use this fractional distillation method. Okay, in order to separate the petroleum products, we use the fractional distillation method. This process is similar to the distillation, simple distillation process, but the difference is there should be difference in boiling point which is below than 25 Kelvin. Okay, there should be sufficient difference in boiling point that should be less than 25 Kelvin. If you take two liquids, their boiling point difference should be between less than 25 Kelvin. Okay, that is the condition. And here also similarly, boiling without decomposition. The apparatus used in the fractional distillation is similar to that simple distillation apparatus only. The difference is here in the fractional distillation apparatus there is one fractionating column is attached to the apparatus. So it can what happen when this fractionating column contain one glass beads. So whenever you boil the solution, what happens? The solution will vaporize, and this beads will provide the surface for the vapors to cool and condense repeatedly. So this glass beads provides the surface area for the vapors to cool and condense repeatedly. So there is continuous cooling and condensation of liquid takes place. Okay, if we want to separate the components of air, which method you use? Okay, we know that air is a homogeneous mixture, means it include different components. Air include different components such as oxygen, nitrogen, carbon dioxide, and so on. So many gaseous particles are present in air. How to separate the gaseous particles? Okay, we use the fractional distillation method here. Okay, here is a flow chart which explains you about how the fractional distillation, how the gas particles are separated from the air. This flow chart explains you about the separation of gaseous particles from air. So first, the air is taken and it is compressed and cooled by increasing the pressure and decreasing the temperature. If the air is compressed and cooled by increasing the pressure and decreasing temperature. Here the pressure is increased and the temperature was decreased. So we obtain the liquid air. Okay, we obtain the liquid air. From that we separate the carbon dioxide and liquid water. Then in the next step, we allow the warm air, we allow to warm up slowly in fractional distillation column. This liquid air is sent to the fractional distillation column. So finally we obtain through the fractional distillation we obtain the different gas particles at different heights. Okay, the height of the gas particles depends on the boiling point. Okay, the gas particles are separated based on the boiling point. The boiling point of oxygen is 183, which is higher, which is greater compared to argon and nitrogen. The boiling point of argon is 186 and the boiling point of nitrogen is 196. And we know that okay, from this activity, from this experiment, we can we obtain the air, we obtain the percentage of air. Okay, percentage of oxygen in air is 20.9 and the percentage of argon is 0.9. The percentage of nitrogen is 78.1. Okay, in the air nitrogen is more. Okay, nitrogen is more in amount. Okay, the amount of nitrogen is more in air. So this is how. Okay, now I will show you the video which explains you about how the fractional distillation is done.
Separation of components in air. Air is a mixture of several gases, and these can be separated by fractional distillation. This is brought about by compressing and cooling of air and allowing it to slowly warm up in a fractionating column. Air is first passed through a filter to remove impurities like dust particles. Filtered air is passed through compressors and it is compressed to very high pressures around 200 atmospheres. Compressed air is passed through a freezing unit where it is cooled to about -200 degrees centigrade. The cooled and compressed air passes through a separator when carbon dioxide gas solidifies and is separated as dry ice. The air which is now free from carbon dioxide is forced through an expansion jet where it liquefies. This liquid air is allowed to slowly warm up in a fractionating column. Nitrogen first boils at -196 degrees centigrade and is separated. The argon, which boils at -186 degrees centigrade, is collected. Oxygen, which has a higher boiling point, is left behind and is collected separately.
Okay, now let us discuss how can we obtain the pure copper sulfate from the impure sample. Means this separation of two components, solid components from the impure sample. Okay, let us understand this through this video.
Purification of copper sulfate by crystallization. The chemicals used for various purposes should be completely free from any type of impurities. Crystallization is an important purification process in which solid crystals are formed from a uniform solution. The different steps involved in the crystallization process are preparation of solution of the impure sample, filtration of the solution, concentration of the filtrate, cooling of the concentrated solution, separation and drying of crystals. Our aim is to prepare crystals of pure copper sulfate from an impure sample. Materials required: crude sample of copper sulfate, dilute sulfuric acid, distilled water, ethyl alcohol, cold water mixture, 250 ml beakers, china dish, glass rod, spatula, funnel, filter paper, measuring jar, test tube, watch glass, evaporating dish, trough, stand with lamp, and sand bath. Procedure: preparation of solution of the impure sample. Take about 30 ml of distilled water in a beaker. To this, add powdered crude sample of copper sulfate using a spatula. Stir the solution gently with the glass rod so that the powder dissolves. Add the powdered sample several times till a little of it remains undissolved in the beaker even if it is stirred for some time. Now, add about 3 ml of dilute sulfuric acid to the solution using the measuring jar and gently stir the solution to make it clear. This prevents the hydrolysis of copper sulfate. Filtration of the solution. Place a filter paper in the funnel and clamp the funnel to the stand. Place the china dish under the funnel. The stem of the funnel should touch the wall of the china dish to avoid the solution splashing out. Pour the solution into the funnel over the glass rod and collect the filtrate in the china dish. The insoluble impurities are left on the filter paper. Concentration of the filtrate. Heat the china dish in a sand bath till the solution is reduced to about 1/3 of its original volume. To avoid crust formation on the side of the dish, stir the solution continuously with a glass rod. To know if the solution has reached its crystallization point, remove a drop of the solution at the end of the glass rod and cool it by blowing. The appearance of a crust or tiny crystals on the glass rod shows that the crystallization point has been reached. Now, transfer the hot saturated solution into the evaporating dish. Cooling of the concentrated solution. Place the evaporating dish containing the hot saturated solution in a trough containing water. Cover the dish with the watch glass and allow it to cool slowly for some time. As the solution cools, deep blue crystals of copper sulfate separate and the crystallization will complete after half an hour. Separation and drying of crystals. Decant the mother liquor carefully into a beaker. Wash the crystals 3 or 4 times with a little ethyl alcohol containing a small amount of cold water. Using the spatula, place the crystals on a filter paper which soaks up the solution. Transfer the crystals on another filter paper and dry them by pressing gently between the folds of the filter paper. Now, transfer the crystals into a dry test tube. The crystals of pure copper sulfate are transparent and blue.
Okay, in this video, here they use the crystallization process. Here they use the crystallization method to separate the pure sample from the impure mixture. Got it? The process of separating a pure solid in the form of its crystals from its solution. Okay, what is a crystallization process? The process of separating a pure solid in the form of its crystals from its solution. Okay, we take the solution, we take the mixture. Mixture is a solution, right? So, which contains all the impurities. So, how to separate the pure sample from it? We use this crystallization method. So, when we use this crystallization method, we can get the pure solid which is in the form of crystal form, which is in the crystal forms. Okay, we obtain the pure sample in the crystal form. This crystallization method is better. Why? Because if you compare the crystallization method to the evaporation process, what happens in the evaporation? When you heat some solids, it will if you take the example of sugar, if you heat that, it will decompose and you will get the chars. Okay, they will become chars. Okay, so dryness on solid. Okay, you will get the dry chars when you heat. Okay, the black color sugar you will obtain, which is not good for the health. So this crystallization method is better. This crystallization method is better in order to get the pure salt. Okay, what are the application of this crystallization method? Purification of salt, which is obtained from the sea water. We can obtain the pure salt from the sea water by using this crystallization method. The next one, for separation of alum from the impure sample. In order to separate the alum from the impure sample, we use the crystallization method. This method is better than the evaporation method. And when you use the evaporation method, sometimes when you filter also, some impure particles may be dissolved in it. It is difficult to separate after filtration also. So this crystallization method is very effective. Okay, how do you get the pure drinking water, okay, from the corporation and all? So how the process, which process takes place while cleaning the water in the water purification system? Okay, in the textbook they have given you a typical diagram which explains you about water purification system in the water works. Okay, where they clean the water, that place we call it as water works. Now let us discuss this through this video.
Drinking water is supplied from the waterworks. A typical waterworks consists of the following components. Sedimentation tank. Water is pumped from the water reservoir and is allowed to stand in these large tanks for a few hours. Mud, sand, and other solid particles settle at the bottom of the tank. Loading tank. Here, the suspended particles are made to settle at the bottom by adding potash alum. Filtration. The water from the sedimentation and loading tank is filtered through layers of sand and gravel in the filtration tank. Filtration is also done through activated charcoal, which affords better quality water. Chlorination. Finally, the filtered water is then treated with chlorine gas, which kills germs.
Okay, in order to understand what is the difference between the mixture and the pure substance, you should know what is the difference between physical and chemical change. Okay, in order to understand what is the difference between mixture and the pure substance, you should know about what is the difference between physical and chemical changes. Okay, what are the physical properties of matter? The physical properties of matter include color, rigidity, hardness, fluidity, density, melting point, boiling point. Okay, color of the thing, then rigidity. Okay, rigidity means whether it is flexible, whether you can change the shape, or whether it will remain in the same shape, or hardness, whether it is soft or hard or rough, like that. Then fluidity. What is fluidity? Whether it is flowable or whether it is constant, whether it is will the substance flow or not. Density, whether it flow or sink. Okay, then melting point, boiling point, temperature difference. Okay, these all speaks about the physical matter about of the object. This explains you about the physical state, physical properties of the object. Okay, and so what is the difference between physical and chemical changes? When you convert the when there is interconversion of states of matter, if you take the example of water, when you boil, what happens? It will convert into vapor state. Okay, gaseous state. It will convert it into vapor. It will convert it into gaseous state. So there is physical change only, but there is no chemical change. Why? Because the water, the taste, the color, nature, appearance, everything will remain the same, but there is just change in the state of the water. Okay, the water will become vapor, so a liquid will become gaseous. That is the interconversion of states of matter is an example for the physical changes of the object. Let me take the example of burning the paper. Okay, burning the paper is when you burn the paper, you will get the ash. So you obtain the new product. So it is an example for the chemical change. There is changes in the state of matter. There is change in the composition of the matter. Okay, the particles are not similar. They are converted into carbon dioxide, and so it is a chemical change. The ash you obtained is a new product. So whenever you convert one object into another state, when you burn, okay, when you obtain the new product, that we call it as we can say that there is a chemical change. If you take the example of burning a candle, what happens when you burn the candle? You will obtain the you will obtain the wax, isn't it? And there is both physical and chemical change. Why? Because before burning the candle, it is in the solid state, and it is converted into water vapor, okay, candle wax vapors. And also there is chemical changes also. That wax is containing all the composition of carbon dioxide and all the air particles, impurities. It obtains the impurities. So there is a change. There is change in physical and chemical changes. So these are the example for the physical and chemical changes. Okay, now let us discuss about the types of the substances. Okay, we can separate the pure substance into two types. They are, one is elements, another one is compounds. So what is elements? Elements can be defined as element is a basic form of matter that cannot be broken down into simpler substance. Element is a basic form of matter. It is a minute, smallest unit of the matter that cannot be broken down into simpler substance. Okay, so that is the basic unit in the matter. So what is compounds? Compounds is a substance composed of two or more elements chemically combined with one another in a fixed proportion. Compounds is a substance which is composed of two or more elements. When you combine two or more elements, such as, if you take the elements such as hydrogen, then oxygen. Hydrogen is one element, oxygen is one element. When you combine in a fixed proportion, you will get the water. So when you take the hydrogen and oxygen element, and when you add in the fixed proportion, you will get the compound. What is that? Water. Water is H2O. H2O is a compound. So it is a basic substance composed of two or more elements chemically combined with one another in a fixed proportion. Got it? So example for the elements. Elements can be classified into three types. Which are they? One is metals, another one is non-metals, and third one is metalloids. Three types of elements. We can in the chemical periodic table, you can see the elements. Okay, metals, we can classify them into metals, non-metals, and metalloids. The next, what are compounds? Compounds, when you combine these elements, okay, when you combine these elements, you will get the metals. You will get the compounds. Which are they? Water, sugar, and salt. So it contains the elements, different elements. This sugar, salt, water, carbon dioxide, then nitrogen oxide, and all sulfur dioxide. All these things. Okay, now let us discuss about the properties of metals. The properties of metal. First property, they have a luster. Okay, luster means shine. They have the shining surface. They shine. Okay, they have the shining surface. They shine. The second one is, they are in which color? They obtain in silvery gray or golden yellow color. Okay, example, gold, silver, copper, all these things, they are available in silvery gray or golden yellow color. The next property is, they conduct heat and electricity. They are the good conductor of heat and electricity. The next one, they are ductile. Okay, they can be drawn into wires. You will get the copper wire and all. So they can be drawn into wires. You can, using these metals, you can make the wires. Okay, thin strips. Ductile. The property name is ductile. The next property is malleable. What is malleable? It can be hammered into thin sheets. Okay, you can make the thin sheets of metals, aluminium sheet, then these copper sheet, all these things. Okay, you can make the malleable, you can make the thin sheets of it, aluminium, iron, all these things, malleable. The next property is sonorous. So when you hit on the metals, you get the sound. Okay, you will get the ringing sound. When you hit, they make the ringing sound. That property is known as sonorous. They are sonorous. Example for the metals, you can see so many examples. You are familiar with the example: gold, silver, copper, iron, then aluminium, then mercury. All these, gold, copper, silver, iron, all these are solid at room temperature, but only mercury is always liquid at room temperature. Mercury is only one metal which is available in liquid state in the room temperature. Okay, now let us discuss about the properties of non-metals. Okay, the properties of non-metal is exactly different from the metals. They display a variety of colors, means there is no particular color for these non-metals. They don't available in particular color. They available in variety of colors. Second property, poor conductors of heat and electricity. Okay, they are not conduct electricity and heat. Okay, they are poor conductors of heat and electricity. They don't conduct the heat and electricity. They are insulators. Non-metals are insulators. The next property, they don't have these properties, these special properties of metals. They are not lustrous, malleable and sonorous. They are not lustrous, they are not malleable, and they are not sonorous. They don't shine. They don't have the shining appearance. They are not malleable. Malleable means you can't make them into thin sheets, or you can't make them into thin wires. They if when you hit on the non-metals, you don't get the ringing sound. Example for the non-metals are hydrogen, oxygen, carbon, chlorine, etc. Okay, these are the non-metals: hydrogen, oxygen, carbon and chlorine. Okay, the third type of element is metalloids. What are metalloids? The elements which have the intermediate properties between metal and non-metal are known as metalloids. The element which have the intermediate properties between metal and non-metal is known as metalloids. Means they have both the properties. Okay, this silicon and germanium, they conduct electricity, but they are not they don't have the properties such as lustrous, sonorous and malleable. So that such type of elements is known as metalloids. So they have some are good conductors of electricity also, some are good conductors of heat also. That is why they have the they show the similar properties of those metals and non-metals. So we can't say this is exactly metal, or we can't say this is exactly non-metal. So such type of elements is known as metalloids. Example is boron, silicon and germanium. Okay, there is another activity which explains you about the difference between the mixture and compound. Let's see through the video, then we'll discuss the differences.
Distinguish between mixture and compound. Using a spatula, take a small quantity of sulfur powder and transfer it into a beaker. Add a small quantity of iron fillings into the same beaker using a spatula. Stir the contents of the beaker using a glass rod and label this mixture as A. Take a china dish and using a spatula transfer a small quantity of the mixture into it. Heat the contents in the china dish strongly by placing it on a wire gauze that is placed over a burner. Stir the contents constantly till a black mass, that is compound of sulfur and iron, is formed. Cool and transfer the contents into a mortar and powder this using a pestle. Then transfer the powdered contents into another beaker using a spatula and label it Black Mass B. Test on the basis of appearance. Take a small quantity of mixture A and black mass B in 2 different watch glasses. Mix the mixture A in the watch glass using a glass rod. You will see yellow powder in which some iron fillings are visible. Then mix the black mass B in the watch glass using a glass rod. No iron fillings are visible in the black mass B. Thus we infer that a mixture is heterogenic and compound homogeneous in nature. Behavior towards a magnet. Place a small quantity of mixture A in a watch glass and a small quantity of black mass B in another watch glass. Show a magnet over the watch glass in which mixture A is taken. Iron fillings cling to the magnet since iron retains its properties. Show the magnet over black mass B. No particles attach to the magnet because iron loses its magnetic properties on forming a compound. Behavior towards carbon disulfide. Take a clean test tube and put a pinch of mixture A into it. Add a few drops of carbon disulfide into the test tube. Shake the test tube well. Sulfur first dissolves, reappears after some time. When in the form of a mixture, sulfur retains its property. Take another test tube and put a pinch of black mass B into it. Then add a few drops of carbon disulfide into the test tube. Shake it well. No change is observed. In compound state, FeS, sulfur lost its original properties after reacting with Fe. Action of heat. Take a small quantity of mixture A in a china dish. Heat the mixture strongly. A black mass is obtained which is homogeneous. A compound of iron fillings and sulfur powder, FeS, is formed on heating. Take a small quantity of black mass B in another china dish. Heat it strongly. No change is observed. The compound FeS does not show any reaction on heating. Effect of heating with dilute HCl. Take a small quantity of mixture A in a test tube. Add a few drops of dilute HCl into it. Cork the test tube. Connect the test tube to another test tube with a bent tube. Heat the contents of the test tube gently. A colorless, odorless gas evolves. Collect the gas in the other test tube through the bent tube. Now remove the bent tube. Bring a glowing matchstick near the mouth of the test tube. The flame dips out, producing a popping sound and with a mild explosion. The gas evolved is hydrogen gas. Now, take a small quantity of black mass B in another test tube. Add a few drops of dilute HCl into it. Cork the test tube. Connect the test tube with the bent tube to another test tube containing copper sulfate solution. Heat the contents of the test tube gently. A colorless gas evolves that reacts with copper sulfate to form a black colored precipitate. The gas evolved is hydrogen sulfide H2S which reacts with copper sulfate to form black precipitate of copper sulfide.
Okay, now let us discuss about the difference between mixtures and compounds. The first difference is mixtures. Okay, what is mixture? Elements or compounds just mix together to form a mixture and no new compound is formed. Okay, which one you say mixture? Okay, if you take the lemonade, okay, or the sugar solution, it is a mixture. When you add the water and when you mix the water and sugar, or when you add water and salt, you will get the sugar solution or salt solution. So there is no new compound is formed. It is not the new compound. It is just when you mix you will get the mixture. Okay, it is a simple thing. Compound, what is compound? Here it is just a physical change. Okay, here there is no chemical change, especially here there is no chemical change. The salt taste will be the same and the water taste will remain the same in that, but it was mixed. Only thing is it is mixed. Here compounds are obtained by the chemical reaction. Okay, elements react to form new compound. Elements react to form new compound. So new compound is obtained. If you take the example of ash, okay, when you burn the paper you will get the new element ash. Ash is a new element. So element react to form the new compound. That is the difference between mixture and compounds. Okay, the second difference between mixture and compounds, variable composition. The mixture have the variable composition. Okay, if you take the air is a mixture. It contains variable composition such as oxygen, nitrogen, and all the argon and all. Compounds, what is compound? The composition of each new substance is fixed. The composition of each new substance is fixed. If you burn the paper, you will get the ash. That composition of the substance, new substance is fixed. Okay, all the particles will remain the same. There is no changes in the particles. All the amount of all these particles will be similar. Okay. If you take the in the water there is fixed amount of hydrogen molecules and fixed amount of oxygen. So that is a compound. Third one, shows properties of constituent substances. When it is mixture, it shows the properties of all the constituent mixture substances. All the constituent substances. A salt solution, if you take the example of air, okay, shows the properties of constituent substances. You can make out the properties of each constituent in the mixture. Okay, that is the property. The next property, compounds. New substance has totally different. The new substance which is obtained is totally different. When you burn the paper, you will get the ash. That is totally different. Its property is exactly different. Or if you take hydrogen and oxygen molecule and combine, when you get the water, that property is completely different. The properties of hydrogen molecule is different. Property of oxygen is different. But when it is combined, the water is totally different from the hydrogen and oxygen. The next property, constituent can be separated by physical method. Okay, if you take the salt solution, you can separate the particles from physical method. How? Evaporation, filtration and all, simple method. Here compounds, here the constituents can be separated by chemical or electrochemical method. You need a little difficult process. You have to use a difficult processes such as chemical or electrochemical methods. You have to use the chemical or electrochemical methods to separate the elements of these compounds. Okay, in today's class we have completed this chapter about is matter around us pure. Okay, if you have any doubts, please ask me. In this chapter we have discussed about the mixture. Mixtures can be classified into three types. What are they? Solution, suspension and colloids. Then the pure substance, which is classified into two types, which are the elements and compounds. Again, this element is classified into three types, which are the metal, then non-metal and metalloids. These are the three types of elements. Then compound. What is compound? Compound is a when you combine two or three elements, you will obtain the compound. So we have discussed all about the metals. Thank you, students.